talked about finding the area of the curve again, but just going back and forth between the notations. We've been doing before the limit of the sum, and yesterday we said that's really just the same thing as the integral. So you had some problems on your homework for writing the integral, and you had some where you were actually calculating your integrals by doing the limit of the sum. Next, I wanted to talk about, we're kind of almost regressing a bit here. We did over and under approximations to begin this thing. And for whatever reason, your book waits until now to throw in another option, which is a midpoint. So we know we did over and under approximations by adding up all the values. And we either essentially did left or right hand sums. When we had that rectangle, we either used the left hand side of the rectangle every time or the right hand side of the rectangle every time. But if you wanted to be even more accurate, if you think about like a curve, okay, and if I'm doing rectangles here, we can do it from the left, we can do it from the right, but the best might be to take the point in the middle to create your rectangles, because then you have some above and some below. Now the downside, do we know at the end if our answer is higher or lower than the true answer? No, there's no idea if it's over or under approximation, but it would be more accurate than only doing the left-hand side or the right-hand side. So that is the midpoint rule. So let's do this one. Evaluate the sum by taking the sample points to be midpoints on the interval 0 to 3 with 6 rectangles. So we're going to start out the same way. We need our change in x. So our ending minus our beginning divided by 6. So our change in x is 1/2 or 0.5 if you prefer decimal form, whatever you like there. So here is the kicker. So we can do the summation formulas for this, but it's almost more trouble than it's worth because we have to try to create the formula. If we're only doing 6 rectangles, is it that big of a deal to plug in the value 6 times? Not really. So let's just do it that way. The width of all these rectangles will be what? 1/2. And we know from back when we did it, then we just plugged in our x's until we had all 6 of them and added that together. So the question is, what's our first point going to be? You know, if I were doing the left-hand sum, I would start at my left-hand endpoint, which would be 0. If I were doing a right-hand sum, we're going up by 0.5, so I'd use my right hand, which would be 0.5. If we want the midpoint, what is the middle of 0 and 0.5? 0.25. So the first x I plug in would be 0.25, or 1/4. 0.25 cubed minus 6 times 0.25. Alright, from here, once you figure out the first one, then the rest of them are easy. Because what is our change in x? 1/2. So to get the next one, we're just going to add 1/2. So 0.25 plus 0.5 is 0.75. And the next one would be, if we add 0.5, 1.25. Alright, next one, if you add 0.5, that's 1.75. Next one, if we add 1.5, 2.25. Last one, if we add 0.5, 2.75. So now we add it. Why did I get a negative value? What does that mean? Negative area? It's a negative area. And how do we get negative areas? It's below the x-axis. Any questions on midpoint sum? So really the only difference is you find your first point by getting the middle, and then you just add your change in x until you get the number of rectangles you need. Alright. Let's do so I keep trying to throw these in. I keep cycling back to them because they're the long ones. This time I'm just asking you to evaluate the integral. So no midpoint, no set number of rectangles, the true value. What do I do? Remember yesterday we said the integral is the same as the limit of the sum of f of x sub I times change in x. So my change in x, we're going to get the real value of it this time. Top minus bottom divided by n, so 3 over n. X sub I is our starting point, plus the change in x times I, so 3 over n I. So we're going to do the limit as n goes to infinity of the sum from 1 to n, f of x sub I. So we're going to plug this 3 over n I for all of my x's. Times, okay, this was a dx. What do we replace the dx with? Change in x. Alright, so this will allow us to see how good our approximation was. So that gives us 27 over n cubed I cubed minus 18 over n I. This is all still times 3 over n. And you can simplify in fewer steps if you're comfortable with that. Over n to the 4th I cubed minus 54 over n squared I. Again, on our last quiz, the thing people struggled with was the simplifying, so try to show more steps, and I think that will help you. Now what do? We do the summation rules. When you do the summation rules, the sum goes away, but I haven't done my limit yet, so my limit is still there. A1 over n to the 4th. What's the I cubed formula? Over minus 54 over n squared times, what's my I formula? We could reduce a little bit. I could cancel a couple of those ends. One of these. 81 over 4 doesn't reduce, but 54 over 2 could. 81 times n squared is 2 plus 1. Can I distribute and break apart these fractions at the same time? So it becomes 81n squared over 4n squared. Yes. So 81n squared over 4n squared becomes 81 over 4. Okay. So 162n over 4n squared would be 81 over 2n. It's 81 over 4n squared. If I distribute negative 27, negative 27n over n is negative 27 minus 27 over n. Alright, now we can do our limit. So anything with an n on the bottom, a number over infinity, goes to 0. So we get 81 over 4 plus 0 plus 0 minus 27 minus 0. So 81 over 4 minus 27. So negative 27 over 4 is fraction. Negative 6.75 is decimal. What did we approximate this at on our last slide? We had negative 7.03, negative 6.75, so they weren't too far off. It was closer than our over and under approximations were. Any questions on that? So the midpoint rule is just another way of getting an approximate area. To get the real area, we have to do this. Let's practice one more midpoint rule. So this one, I'm asking the same thing, but I wrote it in a different form. Use the midpoint rule with n equals 5 to approximate this integral. So we're not finding the real value, we're trying to approximate what it would be. So, we need our change in x. How do we get that? 2 minus 1 over 5, because 5 rectangles. So change in x is 1/5. Or if you're more comfortable with decimals, 0.2, whatever you like. Okay, when we set this up, that means all of these rectangles have a width of 0.2 or 1/5. And we are adding up 5 of them. So we have to figure out what the first one would be. This interval started at 1. The change in x is 0.2, so it ends at 1.2. So the midpoint, what is the middle of 1 and 1.2? 1.1. If you because we want the midpoint rule, so if you started at 1.2, that would be like doing it right hand sum. You'd be picking the right hand. But we know that each of our rectangles would have a width of 0.2. So the first rectangle will start at 1 and end at 1.2. Okay. So we want to estimate the middle of that. If you struggle just looking at it and finding the middle, it's just an average. Add your 2 endpoints, divide by 2. So the first number I plug in is 1.1. And then we add 0.2 each time. So the next one will be 1.3. 1.5, 1.7, and 1.9. And notice my interval ended at 2 and we stopped right before that. We get 0.6919. Any questions on this? So is that the true area? No, it is an approximation of the area. We don't know if it's higher or lower than the actual. Alright. You guys didn't have very much time to work yesterday, so I'm gonna give you a little bit of time to work on your homework. If we start getting done, I might start the next little bit. But I really want you to finish that